Let's look at this question. The question is, a fair coin is thrown 4 times. The random variable w is the number of tails obtained. The question asks us to find the discrete probability distribution of the random variable. So now we answer this question. The coin is thrown 4 times, so the number of tails obtained can be 0. This is that we got heads on all the 4 times, and the number of tails obtained can be 1. This is we got tail at 1 time, but we got heads on the other 3 times. And the number of tails obtained can be 2. This is we get tails on 2 times and got heads on the other 2 times. And the number can be 3. This is we get tails on 3 times and get head on 1 time. And the number can be 4. This is we got tails on all the 4 times. So now we use the lowercase w to represent the possible value. The possible value are 0, 1, 2, 3, and 4. Now we need to find the probability that the random variable equals these values. Now we find the probability that the random variable equals 0. This is that we got heads on all 4 times. So the probability that we get head on the first time is 1/2. The probability to get head on the second time is 1/2. The third time 1/2. The fourth time 1/2. We multiply the 4 1/2 together. This equals 1/16. So this is the probability that the random variable equals 0. Now we get the probability that the random variable equals 1. This is we get tail at 1 time and get heads on the other 3 times. This has several situations. We can get tail at the first time and get head at second time, and head third time, and head fourth time. We also can get head first time, tail second time, head third time, and head fourth time. Or first time head, second time head, third time tail, fourth time head. Or first time head, second time head, third time head, fourth time tail. So there are 4 situations. So for the first situation, the probability to get tail at the first time is 1/2. The probability of get head at the second time is 1/2. The probability of getting head at the third time is 1/2. The fourth time is also 1/2. This equals 1/16. For the second situation, the probability is also 1/2 multiply 1/2 multiply 1/2 multiply 1/2. This equals 1/16. The third situation is also 1/16. Fourth situation 1/16. So all the 4 situations belong to the probability that the random variable equals 1. So we should add the probability of the four situations together. So that is 1 over 16 plus 1 over 16 plus 1 over 16 plus 1 over 16. This equals 1 over 4. So the probability that the random variable equals 1 is 1 over 4. We also can analyze this in another way. We can choose one term from the four terms. Finding the number of ways to choose sum from a total is to use combination. We recall this CNR. This is the number of ways to choose R atoms from a total of N atoms. So there are C41 ways to choose one term from four terms. And in each way, we calculate the probability that the one term we choose is tail, and the other three terms are heads. The probability that the one term is tail and the other three terms are heads is the one term is tail. The probability is 1 over 2, and the other three terms are heads. The probability is 1 over 2, 1 over 2, 1 over 2. We multiply them together to get 1 over 16. So there are C41 ways to choose one term from four terms, and the probability that the one term we choose is tail and the other three terms are heads is 1 over 16. So we should multiply the C41 with 1 over 16. This equals 1 over 4. So this is another way to calculate the probability that the random variable equals 1. So this is also 1 over 4. So this, you see, they are the same. Now we calculate the probability that the random variable equals 2. We can use the method to calculate the probability that the random variable equals 1. We can choose two terms from the four terms. There are C42 ways to choose two terms from the four terms. And in each way, we calculate the probability that the two terms we choose are tails and the other two terms are heads. The probability that the two terms we choose are tails and the other two terms are heads is 1 over 2 multiply 1 over 2 multiply 1 over 2 multiply 1 over 2 equals 1 over 16. So there are C42 ways to choose two terms from four terms. And for each way, the probability that the two terms we choose are tails and the other two terms are heads is 1 over 16. So we multiply C42 with 1 over 16. This equals 4 2 2 multiply 1 over 16. This equals 3 over 8. So this is the probability that the random variable equals 2. So this is 3 over 8. Now we calculate the probability of W equals 3. This is that 3 times we get tails and 1 time we get head. So this also equals 1 over 4. Now we calculate the probability that W equals 4. This is that we got tails on all the 4 times. So the first time, the probability we get a tail is 1 over 2. The second time, the probability we get a tail is 1 over 2. Third time, 1 over 2. Fourth time, 1 over 2. And this equals 1 over 16. So now we put these probabilities back into this table. This is 1 over 16. This is 1 over 4. This is 3 over 8. This is 1 over 4. This is 1 over 16. So this is the answer. This is the discrete probability distribution of the random variable.